This is the front and back page of, I've actually got the right one, the Daily Mail from 1972. This is letterpress. It's a rotary letterpress. So this is a lithographic printing page. You can see how much cheaper and how much lighter that it is to make something like this. This is a lithographic print page. It's aluminium. It's got a special coating on it that's sensitive to light. And from film, you can actually expose an image onto it. So what they did is they had a piece of film made very cheaply. It's been attached to a foil position-wise, and then exposed onto a plate. That plate's attached to a rotary cylinder press, which we're going to see. And then you can print off lots of copies very quickly. This is a picture of a girl crying. I don't know what she's crying. What is she crying about? I don't know what she's crying about. And if you look at it closely, in fact, you don't have to look too closely because it's very obvious. You can see it's made of dots. And if you look at the dots, they're all in lines. You can see there's lines of dots there. And it's called AM screening, amplitude modulation. And all that means, amplitude just means size. And what happens is if you want an area to be dark, so for example around the eye, you have large dots. If you want an area to look light, so under the cheek and the nose there, the dots are smaller. So the size of the dot changes. Even though it's very, very fine and the difference is very subtle, it does give you sharper edges because the dots are in lines. You shouldn't actually see any dots at all, you should see a picture, but it just gives you a slightly different effect. So,
one of the experiments we have done, we haven't done enough experiments, but one of the ones we have done that was quite successful was this. Obviously this is a student's work, and together we first of all printed a little bit of letterpress, printed the colours on the outside, didn't we? And then we're using all the technology we were just talking about. We shrunk the image and the dots to the finest dot that we could find readable. Now this grey area in the middle is in fact the whole of the Bible. And we shrunk the dots down to just less than 1 point on your computer. So if you normally type in 10 point or 12 point, this is just less than 1 point. And it was the smallest we could take it, that every letter was readable. We took it small, we had experiments where we took it right down to 0.5 and 0.4, but different letters sort of disintegrating the E filled in, or the sort of sans serifs, actually this is sans serif, sort of fell off. But it's the King James Bible, and if you look very closely, obviously if you were making that, you couldn't make it with a piece of film, and it's like on the way. We're going to take you into the CTP room in a minute, and it's actually lazy. And each one of those letters is made up of dots. So if that letter just looks like a dot, there's hundreds of dots that make up that letter. And every letter should be readable. That was our thing. And we did have another sheet which the student kept, and I think it's part of his handing, where it showed the type being shrunk all the way down.
this is, I always forget how many pages this is, 24 pages plus a cover. So it's 28 pages. Whenever we're printing, certainly with lithography and reviewer printing or web printing, or we print on a large reel of paper, everything has to be printed in sections. So if you're using your printer at home, maybe an A4 printer, you print out pages. To put those pages together is very difficult. With this, what we've got here, we print in on flat sheets and fold into sections. So to produce that 28-page book, we print in sections of 8. So that's 4. This is an A4 book, obviously. 4 pages, back 4 pages. These 2 pages are a read across or a spread. You may keep working. They're very, very thick paste inks, and they're oil-based. So because they're oil-based, obviously oil and water don't mix. So whenever there's water on that plate, the ink physically won't take. The white area is hydrophilic, water-loving. It accepts water. So
that will stay wet, or it won't?
Yeah. Well, let me show you how it works. So underneath here you've got wet rollers, and in here you've got ink rollers, which I haven't inked up yet. I'll show you that in a minute. So if I roll those rollers over the plate, you can see that glimmer on there now. That plate's wet.
So it holds the water.
This holds the water. This will disperse the water. So because this area is wet and the inks are oil based, the ink won't take there. Because this area is dry, the ink accepts. That's the process of lithography. That's how that works. The other term you might have heard is offset lithography. It's called a rubber blanket, but it's very hard. It's a little bit compressible, and it allows the transfer of your dot from plate to blanket. The reason you don't print from the plate, like you do in letterpress, is because you've got water on the plate. And obviously if you print it from there, the water would go onto the paper would fall apart. So you have to print it from the plate to another cylinder. That's the offset process.
Sorry, did you say, so this is the offset?
Yeah, that lithography is this oil and water mixture. Planographic, which you might have heard, is the fact that it's on the same plane, same level. Offset means you're offsetting it to another cylinder before you print it. So it's going to offset onto here. You'll see in a minute, the image will be on here, and it will be right reading on the plate, it will be wrong reading on the blanket cylinder, because it reverses it. When you take a copy of something, it always reverses. Okay, and yellow. And this is obviously CMYK colours. Obviously, I'm only doing the two of them. And I would weigh them on scales if I was being really fussy. And I'm going to mix those together. And ink is a bit like chewing gum. If you chew it, it gets, the viscosity changes. And the ink tack. Right, so we'll run a little bit of that. There you go. Right reading, wrong reading, and then when it goes onto the paper, right reading again. So you can see these are all back to front. I don't know if you can see that. And if I take a copy from there, it reverses it again. Within less than a second, it's printing wet cyan on top of wet black, and then it's wet magenta on top of wet cyan, and so on. That causes a lot of problems.
Can you slow that down so that it does
You can slow it down, yeah. But it's not really, not massively. The reason we print black first is because it's the least tacky ink, and it's less likely to pull off on the other units. You can reduce the stickiness of the ink, but you have to be careful. If you do that too much, it changes the colour. So there's lots. It's quite a big subject for colour printing.
This is called inline.
Yeah, in full colour. Yeah. So it prints one colour after the other. Like in a literally one button, and that will put that plate onto that cylinder within a tenth of a millimetre. Position-wise compared to all the other plates. Remember, all those dots have to be laid on top of each other in the exact position. Tension, exactly to the right tension. Whereas on the old machines, I had to tension it by hand. It was an absolute nightmare. And that's it. You can see, literally, what was that, 20 seconds? You put 4 of those on in a minute. All I'm going to do now is ink the press up. The damper's already set, so the inkers are in here. You can see some of the ink rollers. If you go down this side here, not like a densitometer which measures how thick the colour is, it actually measures the colour. It will look at the green and say, right, that green's not right. How do I make it right? Add more yellow, and it will adjust the press as it's running. You see them on newspaper presses, it's inline spectrophotometry, so the press is running at huge speeds, and there's a device measuring this colour bar as it runs through. And as soon as the colour changes slightly, it changes it, it corrects it. So the colour will go up and it will correct it, it will go down, and it will go down, and it will go up, and full fret as it's printed. This runs at 15,000 an hour. The newspaper presses run at probably 60,000 an hour because they're on a reel. This is sheet fed, one sheet at a time. Still very quick, but nothing like a web. Obviously, newspapers they run millions. So if you run it, even if you run it 10,000, a million's going to take hours. Run it at 80,000, doesn't take so long to do. And they run huge. This is 8 pages. They run 32-page sections, and it all comes off folded and stitched. Change the pressure, change the colour, move the registration, turn the water down. So in fact, if we do that, we turn the colour on, put the dampers on, let it run for a bit more colour. We'll say, right, it needs more black at the end, a bit more through the middle. Then the cyan prints on top of the black, the magenta prints on top of the cyan, and then the yellow, you can see the yellow, this is the yellow plate, with yellow ink on the rollers, prints from the yellow onto the blanket. Now what happens is, if you look at that blanket, you can see all the other colours are on the blanket. I don't know if you can see that on there. Let me show you the colour bar. Obviously it's very safe, you wouldn't want to put your fingers in there. Or take your hand off. So if you see the colour bar, you can see the other colours are coming off on the blanket. And the reason for that is that the ink is on that, when that sheet gets to here, it's got 3 other colours on it, black, blue and red. And even though we're trying to put yellow onto the sheet, the other colours want to come off because they're wet. That's called trapping. And it's a real big problem on a printing press. So you put lovely bit of blue down, lovely bit of red and black, and when it gets to this unit, this blanket, this rubber, is tacky, it wants to pull the other colours off. And that's a bit of a problem. Off of what? Off the paper, yeah. So you can see it wants to come off. And that is one of the problems with printing wet on wet. The advantages are, when you pull the sheet out, you can see the finished article, it's ready to go, you can run it really quickly. But that's a real downside to printing wet on wet. Some machines have a dryer on each unit, so it prints the black and dries it, prints the blue and dries it, prints the red and dries it. But they're expensive, they're hot, the heat makes the paper curl, there's all sorts of problems. That's one of the downsides. There's lots of advantages and lots of disadvantages. So this is where you would bring it in. This software here will colour manage, it will do imposition and it will do layout. These plates react to a laser. So it's a red light apparently, and it lasers it on there. So each one of those tiny little dots, if we've got 175 lines per inch of dots and they're round dots or elliptical dots, it will burn that dot on there. So the Bible job would have been burnt on each letter. So the letter E would have been made up of hundreds of little dots. It goes around a cylinder. It's punched for registration on the press, and then the plate is burnt with a laser.
Can you reuse those once they're...
Well, you can. They have to be sent away to be done. Right. But yeah, you definitely they'll be sent away and skimmed down or melted down. But you can't. Once it's lasered, the actual image you can't change that image. That's it, unless it goes somewhere else.
Yeah.
But they're designed to be put on and run lots of copies very quickly. So that's where the plates are made inside there, and then.
So if I wanted to cut this stack of paper at 205mm, type in 205, press the button, and that will cut that right there. Take off a millimetre. So you can just cut down to a fine millimetre, or half a millimetre. Now this blade I've had in here all term, since, well, at least 3 months. So it's not as sharp as it was, but that's half a millimetre. And then we might just get away with 1/4 of a millimetre. So if you need any fine adjustments, it's quite easy. With most things in finishing, you always start in here, and that's where you finish copy colours. And here we have 3 knives, 3-knife trimmer, which are 3 miniature guillotine blades that you just see. That will cut the well to the finished size. We have a throat where it's lined up, 2 wire stitching heads to put 2 stitches through the work. There's two different types of glue. One's spine glue, which is thinner and allows it to go into the spine. And one's a fast drying glue that dries in 5 seconds. In a mill, it saws, you can set it, in this case it was 5mm off the spine, allowing all the fresh fibres to allow the glue to go in. It then flows through one glue pot, which is glue up the side, and a second glue pot runs a strip of glue down the side. And the beauty of this is you can use single pages. What you'll hear first, saw, back through it. Glue, and then down here you'll see a thin line of glue which runs to the side. As you flick the cover on, the cover in the right position.